Okay, so picking up where we left off in part one of the video, we looked at unrolling the sides, which we have right here. And in this part, we're going to look at creating the top, and the bottom of this box so that when we print it and cut it out, we can fold it up and have a completely enclosed shape. All right, so the bottom of the hexagon is very straightforward, right? The bottom, if we look right there, the bottom of this is essentially a regular hexagon. We've already created the bottom shape right there. We just have to copy it and move it in location. So I'm going to use the copy command and I'll pick, whoops, let's go back here, pick the object right there. And we can choose any of these edges to put it on. So I'm just going to put it right there, because that seems like a logical place to put it. And there we have our bottom. Now the top is a little bit more challenging, I guess, conceptually maybe, to see what we're talking about. The top is a hexagon, right? That's not doubted. But the hexagon in this case, because it's a truncated hexagonal prism, the top shape is basically a smeared out hexagon. All right. So we have to notice a couple things to get this created properly. The first thing we're going to notice are the two sides here, the two sides that are equal in length and equal in, I guess you could say, angle. And that is the sides well, that's not helpful. The sides right here, which are basically E and F and B and C, right? So we can see B and C right here and E and F are equal in length and in angle, okay? So we're going to use that as our basis for the creation of our top surface right here. What we also notice is the distance between E and F and B and C is precisely 1.75 inches. That's the width across the flats. Now it is also the distance between AB and CD and AF, but we're only interested in BC and EF. So that 1.75, and it's parallel. They're parallel. All right. So what I'm going to do first is I'm going to offset this line 1.75 to create a parallel copy. So I'll go to offset. 1.75 is already there, and I'll offset that line right there. Okay. So in essence, what that is then is I'm going to, and again, I'll copy this over here to make sure that you see what this is. This is E now, which is going to be E. If we unfold it, that's going to be E. Sorry, sometimes it is a little confusing even for me, and I've drawn this a million times. Let's right there. Okay. All right. So there we have EF. Right. Now for the other sides from this, from B, what connects to B? Well, A. B connects to A. Right. And F also connects to A. So what we need to do is we need to find a line somewhere out here where I can draw the line of length, of some length, right? And from B to A, and then I have the same length line from A to F. So how would we do that? Well, if we were drawing this by hand, what we would use is a divider or a compass, right? And we would strike an arc from B equal in radius of BA. And we would do the same for F to FA. And since they're the same distance, where they intersect would be where our line ends. We can do that in AutoCAD using the circle command. Okay, so watch this closely. We go to circle center radius. I'm going to put my center here, and I'm going to strike a radius equal to the distance from B to A. Now remember that AutoCAD keeps track of that last radius. So now I'm going to hit the enter key to go back to the circle command. I'm going to pick my new center right there. And I'm going to hit the Enter key to use the previous radius. Where these circles intersect is where the line BA and AF starts and ends. Very simple. So we go like this from B to A, and from A to F, and then we can get rid of that. And likewise, we do the same for C to D and E to D. So, and let's go do this again. So from B to D, I was going to say it's the same distance, but I don't want to have to prove that to you. So we'll just do the construction again. There we go. So we hit the Enter key, pick, and then we draw a line from here to here and here to here. Right? And then we can erase our construction lines, and there we go. Now let me copy this over here again. So this point right here is D, and this point right here is A, and there's our top hexagon. Okay? Now let me clean this up because I don't want you to have all this stuff in there. Actually, yeah. Let's clean this up. I was just going to say I'll leave this in here, but I want to show you what the drawing is going to look like when you're done, and then maybe we're not gonna have any dimensions on there. There we go. There's the completed drawing. Now we're going to print this on a B-size border, right? So we'll double click in here, do a zoom extents. Bring this in here, set the scale. Let's try 1:1. Look at that, perfect. We squidged that over there a bit, and our drawing is complete. Okay, so I can lock this. Remember, we're not dimensioning it. I don't want dimensions. I don't want any labels. Just finish the title block and border, and then you're done. Okay, so that is creating a development drawing of a truncated hexagonal prism. Okay, or a hexagon box, as they're called in your book. All right, I hope that was helpful. Let me know if you have any questions. I will make another video for the intersection. Okay, and hopefully I'll get that out as soon as today. If not today, then definitely tomorrow. All right, I'll talk to you then. Bye.